next topic which we will be discussing is Ohm's law. Ohm's law is valid at constant temperature. Ohm's law is valid at constant temperature. The current flowing through a conductor is directly proportional to the potential difference between its ends. So here, the current flowing through a conductor, is directly proportional to the potential difference between its ends. So here, Ohm's law is valid at constant temperature. The current flowing through a conductor is directly proportional to the potential difference between its ends. So I can write I is directly proportional to V. To remove this proportionality constant, I into R is equal to V, where R is said to be the resistance, I is the current and V is the voltage. So once again here, my Ohm's law is valid only at constant temperature. The current flowing through a conductor is directly proportional to the potential difference between its ends. From the statement I can write I is directly proportional to V. To remove this proportionality constant, I into R is equal to V, where R is resistance. Here I can write R is resistance. So here, why Ohm's law is valid only at constant temperature? So here, my resistor is a temperature dependence. So if I want to write the equation to show that how my resistor is depending upon the temperature, R of T is equal to R0 into 1 plus alpha into T2 minus T1 degree centigrade, where my RT is the resistance at T degree centigrade, R0 is the resistance at 0 degrees, and alpha is the linear coefficient of expansion, and T2 is the final temperature and T1 is the initial temperature. So by this equation, I can say that resistor is a temperature dependence. So that's why Ohm's law is valid only at constant temperature. And here, why it is valid only at constant temperature? Because my resistance will be depending upon the temperature. To show the relation for the resistance on the temperature dependence, I am having RT is equal to R0 into 1 plus alpha into T2 minus T1 degree centigrade, where RT is the resistance at 0, RT is the resistance at T degree centigrade, R0 is the resistance at 0 degree centigrade, alpha is the linear coefficient of expansion, T2 is the final temperature, and T1 is the initial temperature. Now, when we are coming for the Ohm's law, which is very, very important. Now here, after Ohm's law, we will be discussing the concept as we will be discussing here. The thing is, resistor, what is a resistance? Now when we are coming for I came to know the concept which is a resistance. So here, what is resistance? What is resistance? It is the property. It is the property. It is the property of a conductor. It is the property of a conductor. It is the property of a conductor to stop free flow of electrons. It is the property of a conductor to stop the free flow of electrons. So resistance, it is the property of a conductor to stop the free flow of electrons. So the element which shows resistance, the element which shows resistance is called resistor. Is called resistor. So here resistance, it is the property of a conductor to stop the free flow of electrons. Here I am having, and the element which shows the resistance is said to be, or it is called as resistor. Now here after this we will be discussing about loss of resistance. I am having some loss of resistance. Loss of resistance. My resistance is directly proportional to the length of the conductor. R is directly proportional to the length of the conductor. So here I can say L is nothing but simply it is length of conductor. It is the length of conductor. It is the. My resistance is directly proportional to the length of the conductor. My resistance is inversely proportional to area of cross section. So A is area of cross section, area of cross section of conductor, area of cross section of conductor. So if I am combining my both the equation, R is directly proportional to L by A, where R is the resistance, L is the length of the conductor, and A is the area of cross section of the conductor. To remove this proportionality constant, I am writing R is equal to rho L by A, where rho is said to be, where my rho is said to be specific resistance. Specific resistance, it is said to be specific resistance, or it is said to be specific resistance. Now if I am writing R is equal to rho L by A, from this simply can I write rho is equal to RL by A, can I write? So this is rho is equal to R by L by A. The unit of resistance is ohm, the unit of length is meter, and the unit of area of cross section is meter square. So if I am cancelling 1 meter, I will be getting ohm meter. This is the unit of specific resistance. So my loss of resistance is directly proportional to the length of the conductor. Resistance is inversely proportional to the area of cross section. So if I am combining both, R is equal to L by A. To remove the proportionality constant, R is equal to rho L by A. From this equation, rho is said to be the specific resistance. R is equal to rho L by A. I am writing rho is equal to RA by L. R into L by A. Now, R, the unit of resistance is ohm, the unit of length is meter, the unit of area of cross section is meter square. So here we have cancelled meter and meter. I got ohm meter is the unit which I got. Now, here from my first equation, as I am having R is directly proportional to the length of the conductor, here I can write this as R1 by R2 is equal to L1 by L2. This is one equation I can write. If I have given R1 and R2 and L1, I can find the value of L2. Or if he has given the value of R2, L2 and L2, from this equation, I can find any of the unknown. And here, when we are coming to the second equation, R is inversely proportional to area of conductor. So whatever the conductor we have taken, the conductor is in spherical in shape. So the area of cross section will be R is directly proportional to 1 by pi into R square. By R is directly proportional to 1 by pi square. So if I am writing this equation, R1 by R2 is equal to R2 by R1 whole square. So here what is happening? R2 and R1 are the radius. R1 and R2 are the radiuses of the conductor. Radiuses of the conductor. Now in the same case, if I am writing the diameter also, I can write radius is equal to R by 2. So here simply my R is directly proportional to 1 by pi into D by 2 whole square. So here also what will happen? Simply I can write R1 by R2 is equal to D2 by D1 whole square. Here, where my D1 and D2 are diameters of conductor. So these are the three laws what we are having. Resistance is directly proportional to the length, inversely proportional to area of cross section. By using my first thing, R1 by R2 is equal to L1 by L2. By using the second case, R is directly proportional to 1 by A, where A is the area of cross section. So whatever the conductor will be taking, all the conductors will be in the circular in shape. So area of cross section will be pi r square. So where R is nothing but simply radius of the conductor. So R1 by R2 is equal to R2 by R1 whole square, where R2 and R1 are the radiuses of the conductor. If radius is replaced by diameter, radius is equal to half of the diameter. So R1 by R2 is equal to D2 by D1 whole square, where D1, D2 are the diameters of the conductor.